All right, good morning, good afternoon, good evening, all of you. Welcome to the Lehigh University Energy Systems Engineering Fall Seminar Series. And we've been doing this for a couple of 3 years so far. And we find that this has gotten a lot of interest, not only from the students who are enrolled in this class, but also from industry folks. So we have quite a number of participants or attendees, I should say. And so my presentation is going to be kind of capture an overview of what you would expect to hear and see for the rest of the semester. And we're going to concentrate on the energy transition. And I'll kind of define what it is and what are some of the issues we are facing as we go forward. So my talk is going to be about the electricity infrastructure. It is critical to the prosperity of any nation, and I'll lay the basis for why it is going to play a very key role in addressing climate change challenges as we go forward. And between when we can completely implement climate change, the grid that is compatible with climate change mandates, we'll be going through a long period called the energy transition. And this transition, it'll take place over decades. In some parts of the world, it could be fairly rapid, relatively rapid. In places like Western Europe and in the US, we are talking about a couple of 2-3 decades. But in the other nations of the world, especially India and China, it is going to be a lot longer, perhaps into the latter part of the century. So it's quite a challenge. And really, why I'm covering this is in the seminar series, you're going to be hearing speakers from these different countries, from South America, from Australia, from Europe. And we can see, what are some of the drivers as they go forward. And I want to kind of acknowledge the assistance I've gotten from many of my students in the past, as well as staff members and faculty here at Lehigh University. Okay, all right, so administratively, I'm going to talk for roughly 1 hour, maybe a little less, but I want to leave a lot of time for Q&A, questions and answers. And I'd like the students to participate as well as, of course, the industry personnel who are attending. And the questions will be taken in order of students will have first preference, and then we'll kind of transition to the rest of the audience. You're welcome to stop me at any time, but I prefer that we kind of you can defer your major questions towards the end so that we can cover all the topics in this time. All right, so why is electricity so important? And I'll go through a couple of graphs which kind of indicate why that is so. Let me get my laser pointer working so you can see the running dot. And so this is a picture many of you have probably seen, this not so great news about global warming. It is still, not a lot of, many people may have been convinced, but there's still some ones who kind of question whether this analysis is right. But all in all, we can say that there's quite a bit of consensus, that the Earth is getting warmer. And unfortunately, we've gotten evidence of that in the past few years. This year promises or threatens to be the warmest for the past 150, 200 years that temperatures have been recorded. And that'll beat out what was the warmest, which was last year and the year before. So unfortunately, there's a trail that's being left, which are giving strong indications that we are into global warming. The average temperatures worldwide has gone up like 1.2 to 1.3 degrees. And that's pretty close to what was predicted some time back. Only that this time when will this occur will going to be much later than what just happened. So what I'm trying to say is that global warming is probably a real thing. And global warming is contributed quite highly by three major sectors. I will dwell upon those. One is the electricity sector, which is used for fuels used for generating electricity. The carbon-based fuels that cause global warming are resident in coal and natural gas, which are the major fuels that are still being used in the U.S. and definitely in all other countries around the world. The other topic that I've been dwelling on is we need to make a turnaround where we transition from fossil-based fuels to clean fuels, renewable fuels, sustainable fuels, is going to take some time, even in the best of circumstances. So this bending of this curve is going to be a long, drawn-out process, and unfortunately, nothing is guaranteed. But as this graph shows historically, this graph starts in the late 90s. And it's been steadily growing, and we've been conscious of it for quite some time. And we're starting to take some actions, in the past few years and years of looking forward. So you can see to bend that curve from its steady rise up to 2020 is going to take quite a lot of effort. If we do business as usual, you can see that the baseline temperatures by the end of the century could be 4 to 5 degrees centigrade higher than what it was in the 90s. So this is a pretty formidable issue, and it's not just the technology that's the issue. The technology may be pretty well controlled, but as you can well guess, this is a very geopolitical issue too. There's a question of which countries are going to be laggards, and which countries are going to be prime first movers. That's all dependent upon the politics. Unfortunately, the technologies are not that difficult as perhaps the politics that we'll encounter. So nevertheless, we do need to change our behavior in some ways in how we utilize electricity as a commodity. And I'll kind of show some graphs here which show why electricity has been playing a very important role in our prosperity, and why it's probably going to be the kind of defining answer to decarbonization as we go forward. It's not just how we generate electricity that's an issue, it's also manufacturing processes. It's also mobility. Nearly all our transportation relies very much on fossil-based fuels. And many have conjectured, or at least analyzed, that electrification is going to be an answer that could address the climate change challenges. Not only electricity produced with clean fuels, but also electricity utilized to replace traditional carbon-based fuels for manufacturing and transportation. In transportation, it's easy to visualize that. We are used to hearing about electric vehicles. There are a lot more electric vehicles on the road, but no doubt they're still in a minority as far as the kind of transportation we use today. There are many reasons for that, but we'll kind of dwell on that too. So the top 3 generators of electricity. There we go. Okay. The top 3 generators of electricity are these the 3 listed there. China and India are the growing economies that are kind of catching up with the rest of Europe, as it were. China, of course, has caught up much faster than has India. But these 2 countries are going to be dominantly using fossil-based fuels, as I mentioned, well into the latter part of this century. So we have to kind of plan for increasing carbon dioxide in the atmosphere, And the best we can do is arrest its growth and not stop it completely. But we need to turn it around and turn it around in a time that is somewhat limited. You can see that the largest users of electricity are the countries that are developing the fastest. And not to kind of looking forward, you can see countries in Africa are going to be in the same position as China and India today. They will want to generate electricity to increase their prosperity. Now, the total greenhouse gas emissions by economic sector, this is pretty standard in nearly all countries, with a peak or two, from one country to another. But we concentrate on the big slices of the pie, as it were. Electricity generation, transportation, and industry. They account for more than 3/4 of all the greenhouse gas emissions. And this has changed very slightly year to year and probably changes from one country to another. But many people have, as I mentioned before, they see electricity generation in its clean form, or electrification would be the answer to reducing, if not completely eliminating, carbon emissions, carbon-based emissions from transportation industry and from manufacturing industry. Making concrete are very high as far as carbon emissions are concerned. To use alternate fuels, which again is somewhat into the future, is still a possibility. And if we were to use electrification to kind of encompass all the energy that's required for these three sectors, you can see very easily that a good part of the carbon emission can be retarded as far as emitting it into the atmosphere. So what do we have today? We have a diverse mix of fuels for generating electricity. And there's very good reasons for that. By having all of the above strategy, as it were, to generate electricity, you are kind of minimizing risks, especially for supply chain risks. As we saw recently, especially after the Ukraine-Russian issue, that supply chains were severely affected, and that affected the delivery of certain kinds of fuels in a timely manner. And that has caused a lot of perturbations. But the diversity of fuels was really minimized those perturbations because, especially in the U.S., but countries in Europe were more affected than we were. But the idea of having diverse mix of fuels is always a good idea. Even in the regime of climate change, fewer carbon-based fuels, I think we must retain that option as we go forward. But as it stands today, this pie chart pretty much defines how we generate electricity. You can see natural gas and coal, two major sources of carbon emissions, greenhouse gas emissions, play a dominant role. It still is about 71% of generation capacity. Nuclear plays a small role, but a very stable role, because we've had a lot of experience with nuclear energy over the past 50, 60 years of operation. And we have also had, we have kind of paid a lot of attention to safety. And there was a very good reason for that. In the past few decades, we've seen the accident. We had a small accident here in the US in 1979, 3 Mile Island. But looking forward, that was quite harmless compared to what we witnessed in Chernobyl in 1986 and in Fukushima in 2011, I believe. The last one mentioned, Fukushima, was of course an act of God, as it were. There was a pretty nasty earthquake that caused tidal waves to come into the east coast of, sorry, the east coast of Japan, and flooded the plant Fukushima. So in spite of, Japan was affected by an act of nature, as it were. Chernobyl, of course, was a little more less an act of nature as it was just human error, but nevertheless, nuclear plants, although they are green, in other words, they don't emit carbon dioxide, they are kind of have a very it's very risky when there's an accident that occurs anywhere in the world. As you can well imagine, nuclear power, if there's a accident that happens, the radiation could affect the entire world. We have a small slice of hydroelectric. Those are water stored behind dams. When they are kind of let loose, they turn a turbine that generates electricity. But we have this diverse mix, and it has its pluses, as I just mentioned. We have a diversity, minimizing the risk of disruption. But at the same time, we are even today, dependent very much on natural gas and coal to be one of our major suppliers. There's one nice thing about coal plants is that when they run quite efficiently, especially when they run at full capacity. They do kind of can get started quite quickly, not as quickly as natural gas plants, but nevertheless they're very stable. But you can see coal, unfortunately, is also the biggest culprit, as it were, in greenhouse gas emissions, and so there we got very few options other than to kind of reduce or come up with another way to kind of capture the carbon that's emitted from coal plants. The latter part, we haven't done too well as far as having an economical way of capturing carbon and storing it. So coal plants, we need to continue reducing usage of coal as a fuel. And as you can see, this will have an impact. It threatens our energy security. And as you can well imagine, this is obviously there's a good play for politicians. And so the beat goes on, as it were. Natural gas, one thing in favor of natural gas is even though it does emit greenhouse gases, its impact is 50% or half of what coal plants do. So in a way, they can be a bridge in this transition period as we go forward. But there are other things that make fossil-based fuels a little more reliant, much more reliable, as it were, to be able to generate electricity. We have the largest nuclear fleet. Even though it's 10%, as you can well imagine, we have a large fleet. Only next to France. France has a fleet which supplies 80% of their electricity, and that's they're quite France is pretty much in the lead as far as using green energy, but that's because of their very large nuclear fleet. They've dedicated quite a lot of effort in kind of advancing the technology. I think we need to kind of concentrate on nuclear, especially in advanced nuclear, and I'll be talking a little bit about that as we go forward. So the takeaway that I want you to get from this slide is that, yes, electricity is important. And unfortunately, the major fuels for generating electricity today in the US is still carbon-based fuels that we need to cut back on. So how we cut back on it, the strategies we adopt are kind of defined in the energy transition period. In some ways, you should look at the transition period as the tactical way of a country or a power plant putting together a strategy for decarbonization. The strategy of implementing decarbonization is very much to capture the energy transition. And things need to work out in a positive way as we go forward in the transition. And so because if the transition period is somewhat bumpy, if somewhat unreliable, if electricity is not as reliable as it was when you burnt coal or used natural gas, obviously people will not be very happy because they're so dependent on electricity as a form, as a almost like a civil right. Denial of electricity could lead to some very difficult issues, prolonged outages in different states, especially during hot weather, prolonged outages during cold weather. It can be kind of harmful to humans. There have been cases of deaths, when electricity was cut off, or there were outages during very hot weather, as happened in many parts of the world, especially with climate change is already starting to manifest in many ways. I wanted to share this with you because this is something really important. On the left side, you see electric generation capacity measured in kilowatts, and electricity, and the right-hand side is electricity generated in kilowatt hours. Well, I'll the left side shows the capacity, and the right side shows what really happens on the ground, as it were. And one thing that really sticks out is even though coal on the left-hand side is 31% of our capacity, it's 48% of the energy. Really, what the message is here is that, yeah, coal may be the bad guy, but boy, are we reliant on it to provide reliability. When you need something must run, coal is always there, especially when it's operating to full capacity. Even today, at this graph, as it shows, natural gas is less because it's not used as frequently as coal. And nuclear is similar to coal. Its capacity is only 10% of the total portfolio, but contributes almost 20% of the energy. So that's somewhat the issues that we need to address during transition. You're going to see this imbalance. You're going to see some somewhat despondent reports that this is not working out, but I think we need to weather through this. Coal and nuclear are kind of stalwarts. They're workhorses that we are very much reliant upon to kind of provide us very high reliability. But at the same time, we are facing where we need to kind of cut back on coal, if not eliminate it as a fuel. But we can expand nuclear because, as I mentioned, it is green. But we have to kind of perform research that is being yet demonstrated to work. We've utilized nuclear power in a specific way using nuclear fission. That has worked really well. Light water reactors, it's had its kind of problems that we have found out over the last 4 or 5 decades. But that doesn't have anything to do with technology as much as it has to do with how we operate this, how we regulate this. And I think we're very good at this, and I believe we can make some quantum jumps in the use of nuclear power and increase our nuclear energy, yet maintaining safe operations. This graph caught my attention and is kind of very nicely depicts some of the issues that we're going to run up against in the U.S. And that's because the standards that are set for what percentage of fuels need to be renewables and what need to be non-renewables, in other words, carbon-based fuels, it varies from one state to another. In other words, it's driven by state policies. So what you see in this picture is a kind of a pictorial of each of the states from the west coast to the east coast. And the coloration shown in green and is green energy, and the coloration which is in maroon or brown, I should say, shows fossil-based fuels over the span of 4 years, 2018 to 2022, 4 years. And you can see that most of the Western states are pretty aggressive in reducing the carbon content. But you see wide swaths, especially in the Southeast, in the Midwest, where really the majority fuel is still very much carbon-based, with one or two exceptions. New York, Vermont, New Hampshire, and Maine, they're kind of more aggressive. Now, I grant you, these are states with very small population. States like Virginia and South Carolina and North Carolina, they have a large people moving to the Sun Belt, as it were, from the Northeast. They have larger populations. California, for one, is a kind of somewhat of a one-off, as it were, because it has a large population, and also they're also kind of setting some new methodologies to be able to implement renewable energy. So we have a mix. There are 29 or 30 states that have a renewable portfolio standard, RPS as it's called, and that's basically to maintain a certain minimum amount of renewable energy in their portfolio, or renewable energy that's on their grid, for each year. So they have these renewable portfolio standards that are quite well publicized. But the tragedy is only 29 of the states have a plan. The others have either an aspirational plan or no plan at all. So even if as U.S. makes advances towards the energy transition period, as we go into decarbonizing the grid, and the current administration has 2035 as the goal to have zero carbon on our grid, and 2050 to be net zero throughout in all the things that we do. It's going to be challenging. It's going to be different for different states. Are going to have different pace of change, as it were. But nevertheless, I think it tells you, it kind of lays the groundwork for what needs to be done. It's not going to be easy. It's going to be arduous. It is going to be painstaking. It is going to be sometimes discouraging if things don't work out. And unfortunately, what the progress we've made so far is not enough. And I'll kind of come to that as we go forward. Okay, so this is something that I, in my class I use. What was a grid like, and what is it changing to, or what has it changed to in certain instances? My own career very much started where the traditional grid, but the traditional grid, I mean something where the supply is at one side, say left-hand side of the picture in this particular case, in the top of the picture. You have a plant generating electricity, and it travels over transmission lines and comes to the consumer. So it's very often you never knew exactly where the electricity came from. You did know when you plug in your toaster, when you plug in your hot water heater, or when your hot water heater starts, or when you start your microwave or start your computer, the electricity always there, or 99.99% of the time. And that was a very reliable model. And it has, of course, in the modern grid, it has changed or will change to something a little more complicated, where the flow of electrons is not unidirectional. It's not coming from the power plant and going to the consumer. It could be generated by consumers themselves. They're called, having solar on your residential roof is not an odd thing to see nowadays. In some states, that is more prevalent. You also hear about stories about people bragging about how their electric bill from the utilities, is very minimal because they have solar on the roof. And there are also other stories where the utilities may be pretty, not so encouraging because they were set up under a business model that may be somewhat out of date today. How do we compensate utilities, for generating electricity? And I don't want to get into that in this particular section, but it is a problem that needs to be addressed. So the modern grid now must support two-way flow of electrons, not only coming from the grid supplier, but also from suppliers that have solar on the roof, or that can be collected together. When you aggregate different sources of energy from the roof, those could be packaged together as a power plant, albeit stitched together through the internet. That's called virtual power plant, and we'll talk a little bit about that. So anyway, the takeaway from this is the traditional grid, which was probably relevant in the mid-90s, mid-20th century, is probably giving way to this modern grid, which is going to be the shape and feel and look of what we should expect as we go forward. So there's 3 Ds I like to kind of stress on. Digitization. Digitization is the act of where you're able to digitize information, whether it be the operation of a pump or whether it be the process in a power plant. You're able to kind of capture this data and do some kind of analysis if you need to do, and this way to kind of give you some heads up on what could be anomalous or what could be a problem. And this is very much exploited today in the operations and maintenance aspects of power assets. Decarbonization, as I mentioned, we are going to have to confront climate change, and decarbonization is a solution that pretty much a lot of people have agreed upon, but how you go about it is also the issue. And decentralization, and we were used to a regime where power supply came from a vertical organization, which like a Duke Energy or a Southern company, but it's kind of transforming itself to where it could come from different sources, where it could come from sources that are from consumers themselves. The consumers who supply electricity are called prosumers. That's a word that has been used to describe both consumer and producer of electricity. It's become customer-centric, and the internet has a lot to do with it. You and I have a bigger voice in seeing how things are run or happen. And finally, social equity. In the past, the demographics did not favor low-income consumers. They were sometimes always the bearer of the things that were affected their health. The emissions affected the places where the power plant was operating, and more often than not, those power plants were operating in areas where the demographics were low, where income levels were low, and they were the ones who were most subject to health hazards. So as we go forward in this change, I think there's a large outcry that we have to have social equity as we go forward. We cannot penalize ones who are less fortunate, in the use of this new carbon-free electricity, as it were. As I said, this pace of change is the issue, and it's not whether the change is going to happen. as I shared with you, even in the map of renewable portfolios, standards in different states, you can see the pace of change the change is there, but the pace of change is different in different states. It's very rapid in California, and perhaps in New York too. It's probably as rapid, if not much more rapid than most eastern states. But nevertheless, the pace of change is what we need to kind of look at. Let's just skip over this. I mentioned this. Digitization is to access utility asset information anytime, anywhere, and cloud services provide that. And the ability to collate and aggregate information, provide various services is another advantage of digitalization. And one area that I am pretty familiar with is ability to perform diagnostics and prognostics for operations and maintenance. I'll give some quick examples. What you're seeing here is a system which is very important for a nuclear plant. It's a reactor coolant pump. This is what keeps the reactor temperatures to a moderate level and cools down the reactor. So this, by flushing water through the core, as it were. So this has to obviously work well and work well all the time. The failure modes and effects analysis. How can failure occur? You know, typically the three modes. I'm not going to go into what those modes are, but if you are able to look at, recognize early warning signals from these different modes of failure, you're able to, predict, what could happen if you continue running. And so it gives you a kind of a strategy by which you need to overhaul that system. By the same token, this failure signature can be falsely identified as being troublesome. But those are the things that you need to work with. The fewer false alarms I have, the better off you are. And this idea of digitization, capturing this data, looking at and analyzing it by various algorithms, and they talk about artificial intelligence playing a larger role. It's going to be to the benefit, of the industry. And so this led to many utilities, especially vertical utilities, where they kind of developed this power optimization center, especially if they had different assets. They could have a central place, where all the signals, all the information can be piped in, and automatically it records anomalies. And so this kind of somewhat revolutionized how plants could run their operations. Before, there was a need to have experts in every area of electricity generation at each and every plant. Now, you could reduce that by having a central point where all the information is piped in and analyzed, and automatically it alarms whether there's issues serious enough that you need to have an outage and take care of that, or can you delay it till the next outage period where you can change the fuel, when you were changing the fuel for a nuclear plant, for example, where that could help out. So this has really played a role for 10, 15 years in our industry. And I was very fortunate to have been involved in some of this, but it really kind of opened the door for what can happen, in a where all these three capabilities, digitization and decarbonization and decentralization, will be playing an increasing role. Again, decentralization is proliferation of distributed resources at the consumer sites. Net metering is looked at by many utilities, many states, sorry. And this is giving way, net metering is giving way to something different. I think virtual power plants could be one path, but nevertheless, it is definitely evolving as we speak. If you were to look at some of the things that are being done at the edge of the grid, as it's called, where the electricity is distributed to distributors and comes to a consumer, the consumer could have a whole bunch of things behind the meter, as it were. It's not just the appliances that they have been using, but you could have a solar on the roof. So that's not only generating electricity for home use, but it's also sending electricity back into the grid. And then there's, of course, electric vehicles that could play a role. So if there's a charging infrastructure built into the home, that could play the same role as your solar on the roof. And the last bullet is kind of interesting. It's where if you were to look at all different homes or all different offices where they have solar on the roof, they have electric vehicles. Through AI, you could aggregate this as a virtual power plant. And this is so exciting because to provide a virtual power plant, based on configuration, stitching together, as it were, in cyberspace, you're able to do some of the things that people do today to supply supply a load when there's with a very strong ramp. You need to use fossil-based combustion turbines, which is they do the job really well, but at the same time you kind of having to take the burden of having more greenhouse gases. So you can imagine in the future you could look at virtual power plants which could substitute providing the ramp up needs as we have more and more solar, which kind of disappears all of a sudden, when it's dusk time, and you need to make up increased demand for power or energy when you have solar kind of bowing out, as it were. So virtual power plants play a role there. This is the idea. It can be utilized, and this is probably very looked upon very favorably in urban cities, where bringing in heavy equipment in and out could be a problem. This could be an interesting way to go forward. As of now, there's no quote virtual power plant that has demonstrated it can work reliably. But I think in due course of time, there will be such an event. And again, decarbonization, that's been the driver for all the things that I just explained. And the challenge is, of course, to maintain global temperatures to be no more than 1.5 to 2 degrees centigrade above baseline. And I forgot to mention that baseline now is the baseline temperature was what the Earth was before in the Industrial Revolution. So that's the baseline that you want to kind of target. Some of the things that are happening in the other fronts, I mentioned that it's not just electricity generation, but vehicles. China and India have of course, they're starting off with a low base of vehicles on the road, as it were, but definitely they are the ones that projected to grow most rapidly in the use of electricity for their transportation needs. Now, the transportation needs are not exactly the same as what we have here in Europe or in Europe. I just read a news item where electrification of what are called scooter rickshaws. Okay, I don't know if you've heard of one of those. Those are three-wheelers, but having those electrified, could make a large dent in the number of mobile vehicles that could be electrified. I mean, we don't have them here in the U.S., but in many parts of Asia, they're very common. China, as you probably read in the newspapers, they're gotten a variety of electric vehicles on the market. Some of them are definitely a threat to the economies of Europe and the US, but nevertheless, they have some very strong plans to kind of electrify their fleet of vehicles. Again, keep in mind that the types of vehicles that are utilized in China and India are somewhat quite different from what is required in the US and Europe. But who knows? There may have to be a behavioral change, to kind of match that capability. And if you look at news closer to home, how are we doing in climate change activities, commitments, and this is just something that the Rocky Mountain Institute has kind of put together to meet 1.5 degrees centigrade aligned pathway by 2030. It is the white line here. The only utility that seems to be on track, actually utilities I should say, are Excel and Nextra they call it. The other three, which are pretty huge utilities, Southern Company in the Southeast, actually all three are in the Southeast, where they're large utilities. They are kind of, obviously, they fall short of their goals. And more negative news, again, from the same institute, Rocky Mountain Institute. They looked at what are called IRPs, the Integrated Resource Plan. That is, each utility has to put out what is called the Integrated Resource Plan. Once upon a time, it was at a very kind of collegial rate, once every 5 years, once every 10 years. But now, many of them are having to do this every year, if possibly every year, sometimes every 2 years. But this is demanded of all utilities. And you can see that even looking at what is in their IRPs, integrated resource plans, and what they're targeting are still falling short by 2035. So again, something has to happen more rapidly than what has happened so far. And we need to make these changes under even more difficult circumstances. We are falling short of interim goals. Technology for carbon capture, fossil fuels is falling short. And then don't have to add the three largest polluters, China, US, and India, have their differences. So they're not going to all agree. And what I see is the fourth bullet pretty much mentions that I think the US has to have a leadership role. I think if US does not make that commitment to be net zero by 2050, I don't think that's going to inspire other countries to follow suit. So that's the kind of despondent news. But I think all in all, we'll get there. I'll quickly go through why nuclear energy needs to get another look at. I think it's gotten a lot of attention in the new IRA and the IRA, Inflation Reduction Act, right? This thing I kind of shared with you, where nuclear energy is a larger contributor to total energy than is capacity. In other words, nuclear is very reliable. Once it starts running, it runs till the next outage, given that if you don't have any operational and maintenance issues. I also mentioned that our operational and maintenance practices in the US for nuclear plants has been fine-tuned and well-honed for the last 5-6 decades of operations. I really must hand it to that industry because they have a very good regulatory body, which was obviously always acted as the, not as a quote, they played their role very accurately as a regulator. So when they saw problems, they kind of pointed them out. So we've got a very good operational history. That does not guarantee that if we have a look at advanced nuclear, that we will do just as well as we did in the past 4 or 5 decades. But there's a good shot that we'll have the expertise to kind of make that happen. Good news about nuclear, even if you look at the most quote renewable energies, wind, hydropower, and geothermal, it still is for life cycle carbon emissions. Nuclear is the lowest of the lot. So when you look at cradle to grave carbon emissions, nuclear plants are projected to be very low footprint. There are all these wonderful things that are taking place. Small modular reactors, which is kind of it's a fission reactor, but just been which has been manufactured in a manufacturing site and brought to the site for implementation. What we were doing before was actually building the power plants at the site. And that takes the uncertainty away. And the problems we ran into were that each design, even though they were supposed to come out from the same family of designs, was quite different because they had to adapt that, to the different localities. So you had a kind of if you had a Mark III GE boiling water reactor, for example, that design could be so different from one city, one state to another, one country to another. And so it was kind of a mishmash. The SMRs is kind of an attempt to not only standardize this, but have them be more flexible in their generation. What I mean by that is, SMRs can also pack a punch. A typical nuclear power plant is typically 700 to 1,000 megawatts or 1 gigawatt. SMRs you could have a kind of a pack, a 6-pack, a 4-pack, where this SMRs can each of them be quite small, like 75 or 100 megawatts, but you have 3-4 of them around, so the total capacity could be up to 300, 400 megawatts. So not too shabby. There's something else about nuclear plants versus other renewable forms. Wind and solar require a lot of space, a lot of space that cannot be used. And so that, space is not easy to come by, especially from a permitting standpoint. So SMRs could be not only a very important player as we go forward with nuclear power, but they could also, we won't have to face the permitting issues that you have to face. The nuclear waste, and I know this kind of concerns a lot of people. I don't want to kind of repeat what some pro-nuclear folks say, is that all the nuclear waste that we have generated so far that will not occupy more than 3 feet space in Foxborough Stadium in Massachusetts. Yeah, well and true, that's true, but nuclear waste has a lifetime of thousands of years. We cannot afford to take that lightly. What is coming to the fore is some new advanced reactors that can utilize the spent fuel of our existing reactors. The fuel that is spent on a typical fission reactor today still has 90% of its life left. So there are some technologies that are looking at utilizing the complete, bring it down to zero, as it were. And so this could have a very long operating history without going through an outage. They're promising, but it has to be demonstrated. I think I'll skip this. So I'm going to kind of wrap up. There are 5 difficult tasks that I see during the energy transition period. Again, the transition period is where it will take us from where we are today to where we want to go. I mentioned that this was for decades for some countries, and maybe a few decades for US and Western Europe. But these are things that could derail our efforts or discourage our efforts or just, getting the ones who were in the sidelines, the peanut gallery, as it were, to say, I told you so. Increasing nuclear, I kind of painted a somewhat of a rosy picture. It's not unrealistic, but at the same time, nuclear takes a long time to be approved. I think we need to improve the processes, but again, improve processes without reducing the risk. Tall order. The second bullet, batteries for long duration storage. It could be the answer for how renewables could really have a pretty good future, for the future grid, because batteries allow you to store energy. And if you could store them for a longer time, especially when you have excess solar, you can utilize the rest of it at nighttime. Another way of looking at batteries is, people have said this before, that if you look at Northern Sahara, if you look at areas there, and I'm not going to get into some of the environmental issues, but you have enough space there where you could generate all the renewable energy that you need for Europe if they wanted a dedicated submarine cable, as it were, to a hub there in Europe. Again, easier said than done, but it tells you what you can do with long duration storage. And this is where we fall short, where we haven't come across, or we haven't demonstrated reliably that we can store gigawatts of power for long durations, 8 hours, 10 hours, what they call grid scale batteries. There are some very good steps that have been taken already, and they're promising. So they show promise. The third bullet is permitting, and this, you would expect this to be somewhat easy, but you can see there are political motivations behind permitting sometimes. But some recent acts by the FERC, which has speeded up transmission lines implementation. What has followed that is looking at replacing the existing conductors by newer materials that can increase the capacity of existing transmission lines. They call that reconductoring, but that's one of the most promising steps that I have seen or read about that would accelerate the use of renewable energy. That's because renewable energy usually is in the Southeast, Arizona, and West Texas. And the users could be up in the Northeast. You need long transmission lines. But what if you could replace the wiring that is there in the existing transmission lines with these new conductors whose capacity is so much more? Those reconductors they're not experimental lines, but they're actually been demonstrated they can work really well. This fourth bullet is innovation. Not only utilities inviting innovation, but the PUC. Their partners who authorize utilities to operate, come up with more innovative ways to manage, come up with a business model. And the last bullet is kind of, when you talk about electrification, well, if you're electrifying everything, well, the demand will go up. So utilities have faced a regime over the last 20 years where the demand has been flat. So imagine if the demand is flat. In fact, 2007 to 2022 is fairly flat, but they're predicting a pretty heavy use, and it's not unusual, because if you're going to transform your industry to a zero carbon industry using electricity or products for electricity, for example, you use SMRs to generate electricity to produce hydrogen. Hydrogen as a fuel could replace carbon-based fuels. It could be a fuel that could be utilized for combustion turbines. We're not there yet, but can be. So the demand was to go up that 2 to 3x. Is our infrastructure ready to make that happen? So each of these tasks are difficult in their own right. They are vast in their scope, and I wanted to kind of share with you what you would expect for the next few weeks in our seminar series. The next talk would be by Frank Felder. He's a consultant on resource adequacy modeling and policy in energy transition. Again, this is somewhat gets into the weeds, but Frank will be presenting this because once you have the capacity, and this capacity is provided by renewables, you need to have more adequacy to be able to assure that you can cover all bases and maintain the reliability that we're used to. So how we go about doing modeling and what are the policies that could be encouraging it will be in this talk. On September 16th, we have a person from Uruguay, which has 95% clean grid, and they're wrestling with transmission planning with high penetration of renewable resources. Energy transition in India is the next talk on September 30th. India, of course, has got a very large capacity of renewables, but as I mentioned before, when it comes to utilization of their capacity, they rely very much on coal plants, and they will continue to rely on coal plants, much to their detriment too, because overall health is going to be affected. Not to talk about the carbon load on the globe is going to be even more. Energy storage and the energy transition will be a person from EPRI will talk about it. We'll have a talk from Australia, and in fact, this time for this seminar will be slightly late to accommodate Leo. He'll be talking about the energy transition in Australia. And then the last three, we have, we talked about electrification as an answer to meeting climate change goals. David Porter is managing this effort at EPRI. He'll be presenting on, what are the paths forward. Energy transition in Europe. And finally, this will be a presentation by TVA, which is bidding on a contract to look at grid interconnection and disadvantaged communities initiatives. So we're looking forward to a very exciting time. Hopefully they'll build up on some of the things you heard today. But I want to also kind of just point out some of the references, these resources that we utilized in putting this talk together. And I'm 2 minutes over time, so I'm going to stop talking and stop sharing too, so I can see all of you. All right, so if you have any questions, please unmute yourself, introduce yourself, and ask that question. And I'll open the floor to students first. Students? Anybody? I'll open the floor to anybody want. There's something in the chat box here.
That's me, Rudy, not a question.
Okay. Jean, Rockland, Maryland. Yes, Vermont does show 100% of its energy from renewable resources. More than likely they are importing a lot of this from the neighboring states. Vermont is a small state. They can make things happen without too much disagreements. And so I don't think it's an anomaly. This is they do get 100% of their energy from renewable resources, but they're a small state. It's easy for them to do. So, Jean, I hope I answered your question. Any other questions?
Hello, good afternoon. Sorry, I just raised my hand. I couldn't see anybody else in the line, so I'm jumping in if you don't mind. Tushar Khanna here. I'm energy manager at Equans, so Toronto, actually. Quick question for you, if you don't mind. So my work often has to do with larger facilities, and there's a distinct drive to push towards net zero for government buildings. But in a lot of these, you often have to plan in for redundancies, which is not working well with the transitioning grid. Could you please give us some thoughts on how to have redundancy and supply for government buildings or critical buildings while still transitioning the grid to a greater shift in renewable or baseline producers?
Yeah. Tushar, I tell you what, I didn't come across very well. Did you ask for adequacy?
Yes, adequacy and redundancy, especially for larger facilities or government buildings, which need constant supply while trying to transition with an aging infrastructure and change in the supply.
Yeah, and so you want me to comment on that, or?
Yes, generally, if you had any thoughts on the matter, or if that needs to be a different focus than the general plan in the coming years.
Right, and the fact we haven't, right now we don't have a policy where we don't have operating experience. I mean, that's really the, if we were to go 50% renewables, how are you going to manage the adequacy issues? How are you going to manage the reliability issues? Fortunately or unfortunately, we're still early stage, still developing the game plan, as it were. So I don't think I can guess, but some of this could be highlighted in the next talk on adequacy. More than likely, the adequacy with current ways is being described is probably not enough if we have high penetration of renewables. But at this point, I'm not the expert in this area. I can only speculate that this is going to be more difficult, but there'll probably be a way, Tushar. I hope I kind of addressed part of your question.
You certainly did. Thank you. Appreciate it.
But yeah, as I said, I don't want to say stay tuned, but it just so happens the next talk is about resource adequacy in the case of high penetration of renewables. So hopefully there'll be some light shed there. Suzanne, do you have a question?
Yes, I did. I was just going to jump right in. And to some extent, it sounds like the next presentation might actually address the question. But in terms of the resource adequacy, I looked at some of the suggestions about moving forward. And I would have expected that you might have had included like more interregional transmission to allow for greater flows between regions. And I'm just curious about that aspect, if you have any thoughts or opinions on that. And I'll probably save my resource adequacy questions for the next presentation.
Okay. Suzanne, that's a good point. The more interconnection, I'm not the expert in that area. And I hope one or more of the future talks will address that. I know there are some, Texas, for example, just recently allowed for any kind of connection to their grid, through Oklahoma, which is very much restricted in what they can and cannot do. But I think interconnection, it will help a lot. In fact, the story of Uruguay is that they are getting most of the renewable energy, or a lot of the renewable energy, from their neighboring countries, Argentina and Brazil. So, I think this interconnection, there's also, I think FERC has acted upon reducing the times for approval of renewables onto the grid through transmission lines. And they've also taken away the burden that the first mover who's asking for the interconnection would have to kind of foot the bill, as it were. I think they're making it a little more even, as it were. Again, I don't know all the details. They're making the process simpler.
Rudy, Richard Mack has a question in the chat.
Mhm. Ah, Rich Mack. The question was, when discussing transmission grid issues, you mentioned reconductoring and refer to new materials. Can you elaborate on this? Is it DC versus AC? It's actually a bit of both. It's both DC and AC. The AC part I know a little bit about. As reconductoring, it's introducing lighter weight. Now, right now, to maintain stability of transmission lines, they have to put a lot of steel along with the aluminum that's utilized for conduction, and that adds weight. I think they come up with some materials which are much lighter, but have the same capability as present-day conductors to not only accommodate higher capacity, but do this more reliably. So the whole point of reconductoring is, you're replacing the current wires, which consists of aluminum and steel with aluminum and some fiber, I'm trying to think, is fiberglass material, or it's a composite material, I believe. It's composite material. And that can kind of increase the capacity. That's one of the cheaper fixes. As far as DC is concerned, there's not much activity in DC transmission that's taking place here in the US, but there is quite a lot in China.
Sorry, if I could just jump in for one teeny tiny second. So I think what you were thinking about when you said the composite material is GRP, because glass reinforced plastics are becoming pretty popular in applications where they're trying to replace steel.
I'm sorry, Tushar, I didn't get you at all. Could you please speak?
My apologies, my connectivity is a little poor. I think the one that we're talking about is GRP, which is glass reinforced polymers, because those are becoming rather popular as framing choices where you want to avoid using steel due to weight concerns.
Okay. Any other questions? If you want to use the chat box, please go ahead and do that. And frankly, I think maybe better for me because I'm having trouble hearing some folks. Okay. We still got a few minutes. If you want to ask your question, go ahead, unmute yourself, or just type it into the chat box.
Hi, Rudy. I hope you can hear me. It might be easier than me typing.
All right, Suzanne.
I know you indicated that this is not about rate making and rate structures, but to a large extent, it does seem that the different regulatory constructs may not be all that conducive to the energy transition. And is this something that maybe as an industry we need to really push harder on so that businesses can still make a buck, but
Yeah.
yet
Yes, Suzanne, excellent point. I think rate making and rate design is so key. We need to come up with innovative structures. right now, the PUC, as I don't have to explain to many of you, that right now the utilities are rewarded with more capital expenditures and much less on innovation, unfortunately, because nobody says, "Atta boy, just lower the rates some more." And so I think there needs to be some give as far as what PUC should be tolerating. But ultimately, the PUC is us, customers like you and me. And we'll shout to, I think we will scream if the electricity bills go up. In fact, I think the electric bill just went up. The average electric bill in the US has gone up almost 50%. I think it was kind of hovering around like 8 or 9 cents a kilowatt hour. It's easily 15 to 20 cents a kilowatt hour today, and likely to go even higher. And if you want that kind of reliability we're used to, that is on demand, that's probably going to be a higher price. I think innovation needs to be there at the PUC end, and ultimately that means it has to be backed by the people, citizens, you and me, who are willing to tolerate this. But I think just throwing money is not going to help. It's got to be innovative. Dynamic pricing has been something that people have talked about, and I think you can do any kind of analysis. You can show that dynamic pricing is probably best during the energy transition and ultimately net zero. But selling that is going to be so difficult. And innovation is also needed at the FERC level. Well, good point. But I think they've heard the message. They've made some moves. Let's just hope that it happens, keeps happening.
Thank you.
Okay, let's see. We still got some time. I'll keep the floor open for a few minutes. If not, we'll kind of sign off. Questions from students? From the audience, general audience? Okay. Well, thank you again for your interest and for your attention and your questions, of course. I just want to kind of let you know that this is an opening to the seminar series. I hope you're able to attend. They all occur at 12 noon on Mondays. The schedule is available. And then we'll have a total of 9 seminars, including the one that you just heard today.
I want to interrupt. The one difference is the Australian one by Leo is at 3:30 p.m.
Right, except the Australian seminar, which is going to be held 2 hours later. But God knows what time it's going to be wherever it is in Australia. But we've done this once before, so I'm pretty sure it'll work out okay. But if you have any questions or the talks that you would like to see in the future, or any questions you have about the talks you'll be hearing in the future, or the talk that I made just now, please don't hesitate to either send me or Susan a note. And I look forward to kind of seeing many of you in subsequent seminars. Thanks a lot.
Thank you, everyone.
Thank you, Professor. Have a good one.
Bye-bye.